Yuriko. She is a plasma researcher for Cryptoeconomics Lab, and I'll pass on the mic to you.
Hello everyone, my name is Yuriko. I'm here from Cryptoeconomics Lab. Today I'm going to be talking about plasma chamber, our plasma implementation, introducing its spec. So it's so cool that there's been a lot of discussions on plasma implementation designs on ETH research proposed by those genius plasma researchers out there. And while looking at these cool implementation designs, we thought we want to implement actually usable plasma and deliver it to developers to produce more of real-world use case of plasma as soon as possible. So we implemented this effortless apps development framework on plasma called Plasma Chamber, inspired by plasma cash flow. By the way, our lead engineer Shuhei and CDO Shago has been trying to actively post their findings and our design on ETH research. So please comment and suggest, leave any comments or suggestions if you see them there. So inspired by plasma cash flow, it employs some marketry to avoid mass exit, allowing merchant split, so that NFT, non-fungible tokens, can be treated as fungible by defining start and end. Okay, so let me start from the start. So yeah, it employs some marketry to avoid mass exit, allowing merchant split to enable treat non-fungible tokens as fungible by defining start point and end point, what token ID. So what you can do with Plasma is so much, from improving TPS, of course the security guarantee, to enable users to use dApps on top of with less gas cost, because operators can pay for them. And these are the common qualities of Plasma. But in addition, dApps built on top of Plasma Chamber will guarantee to work on mobile with instantaneous finality. So we implemented a transfer app and with collaborating with DAI stablecoin so that end users can even enjoy low volatility. So I'll show it to you later. So let me dive right into our implementation design. So first, let me start off by our fundamental security model. So with Plasma Cash and Cash Flow design, there was this attack possibility called edge case. So Alice sends her money to Bob, but operator withhold this transaction, and Alice notices it and tries to exit, and Bob tries to exit as well, because she's like, wait, my money is not sent to Bob correctly, even though my balance is reduced from my account. But operator reveals its transaction and immediately challenges these exits of Bob and Alice, and that's the attack case. But we solved this problem by putting priority keys with the parent transactions number, so that Bob can exit earlier than operator. This is quite different design from Plasma groups or any other Plasma cash flow models. So we posted this design on ETH research, another simple exit game. So next aim is gas cost and proof size reduction. defragmentation. Defragmentation is implemented to reduce gas cost fee for exit to users, for users to exit. So with plasma cache and cash flow design, the process of assigning unique IDs for each segment of UDXOs optimizes the proof size of each user has to hold, but there's another problem arose here. So each segment requires the same amount of gas cost to exit. The more fragmented these segments are, the more gas cost will be required for users to exit. So we solved this problem by combining all those segments by users so that the gas cost will be reduced. And also there's an update with this implementation. I just got a message from our lead engineer that we are partially done implementing predicates originally proposed by Plasma Group, covering this defragmentation feature using both atomic swaps and multi-hop swaps. So there's a code up there, so on our GitHub, so please check it out if you're interested. Next aim of the implementation is proof size reduction. Plasma checkpoint. Plasma checkpoint is implemented to reduce history data that each user has to hold on their wallet. So by creating this checkpoint where everyone temporarily agrees that all the commits before this checkpoint is finalized with regular interval, the size of the history data that each user has to hold will be reduced to some small constant. And you might think, how is it even possible to trust all the commits by an operator to root chain without verifying them without everyone's consensus? So to answer the question, there is an there is a challenge period prepared after this commit, this checkpoint, and in our implementation is set 3 times longer than the exit challenge period. So in order to make sure the security, we have to set this checkpoint challenge period to contest the current state, and if this checkpoint doesn't get any invalid state, then this checkpoint is finalized. So let's talk about fast finality, which is going to be the highlight of this presentation. So normally, combining plasma chain block time and root chain block time times 6 to 24 blocks, which is recommended number, normally it takes 2 to 7 minutes to get finality of plasma. So the TPS got improved, but time to finality has not been. And with fast finality feature, we try to achieve fast finality, instantaneous finality within to the transactions in plasma chain with security guarantee of operator's collateral. So in the plasma chain, there's an operator, service provider, and customer. So service provider has to buy this bandwidth with FF token. Then operator can provide fund security and this fast finality to customers from his collateral, just in case anything wrong happens in the plasma chain. So this is how FF contract works. So Alice wants to buy her coffee from coffee shop owner Bob. So she sends her transaction with her signature. Then Bob sends this transaction to operator with his signature. Then operator sends it back to Bob with his signature. Then here now Alice, Bob, operator, three of them agrees with each other that let's just confirm Alice transaction. Then operator can secure this transaction with his collateral. Then Alice gets notified that. But what if operator was malicious and break the promise? Then Bob can dispute this operator, claiming to fast finality contract, saying that operator didn't include my transaction. I'm supposed to be getting money, but he didn't include this transaction to the root chain. Well, he can't prove that his transaction was not included because he can't really turn in any proof, any evidence. So there's a challenge period prepared after this dispute, and all the dispute scenario is explained in our GitHub wiki. So please go check it out. Those of you who wondered how fast it really is, as I mentioned earlier, we created this transfer app collaborating with DAI stablecoin on Plasma Chamber. So let me show you guys the demo video.
May I help you?
Can I get caramel macchiato?
Hot ice?
Hot, please.
Can you scan the code and please send to that?
Okay.
Die.
Okay. Transaction is
Okay.
like within a second.
Here's a coffee.
Okay, so that was me not really good at acting. Anyways, I put up the links to these apps that we used as a user and as a shop owner and the video. So please go to the link there and play with them if you're interested. And it might be difficult to see all the transition of the screen, so I put up the screenshot of each screen, each UI. And so first I didn't have any DAI, but my friend sent me DAI. Now all you have to do is just putting my address on the box and click fast transaction button, calling fast finality function and contract. Then I get DAI in my account. So what we can do now is transfer multi-sig payment channel ERC20 atomic swap on Plasma, but what we wanted to originally was deliver this effortless dApps development framework to develop dApps developers and create more complex, more flexible any dApps and produce more of real-world use cases of dApps. So from now, we're going to be focusing more on to develop complex smart contracts like voting systems, multiplayer games, collaborating with PLAPs and predicates proposed by Plasma Group. And in order to do this, we believe there's more research and development needed to brush up those implementation designs proposed. For example, commit aggregation, cross-chain atomic swaps, visual languages. So it'll be our pleasure if you can collaborate on research and development. And of course, we develop stuff open source. So you guys can take a look at our GitHub, and yeah, it'll be our pleasure to collaborate together. So this is our GitHub repo, and oh yeah, so there's a video that our wallet engineer made for today. So let me wrap up my talk while playing this video. Okay. Yeah, so our GitHub repo is up there. So if you guys can take a look at our specifications, and if you're interested in learning more about us, there's our Twitter account there. So please stay tuned for any updates, and I'll be around here until the end of the day. So please feel free to contact me, reach out to me, and let's talk about Plasma. So embarrassing, but alright, thank you very much.
For a second career, I think you could be an actress. There we go. You actually did pretty good. How many times did it take you
So many mistakes.
Right, okay. So that's actually really exciting, and I think that video of being able to buy that coffee was amazing. Given that there are like many versions of like many flavors of Plasma out there, do you think that sort of you would be the first out to be sort of using that and people adopting it?
Yes, I think we reached out to like real world adoption earlier than everyone, because we actually used this app in a real world. So I thought that was very cool, and our team is working very hard to actually produce something that we can use in a real life. So yeah.
Given that someone actually complained that we didn't have coffee early enough, maybe that's something you guys should maybe do that next time. So thank you so much.
Thank you.
My pleasure. Okay, so next up we have Lane Rettick, core developer at Ethereum Foundation, and he will be talking about Ethereum 1x roadmap.